Alright, next, 18, or 19. With 19, the denominators are not the same. Okay? So we have to make them the same. That's the hardest part. We have to make them the same. So I can't just say, okay, I'm going to add a -6 to this, and it'll be, you can't do that. Right? To make the denominators the same, you have to multiply by something. Okay? So the one cool thing about this is using what's called the conjugate. Right? If we use the conjugate, or not the conjugate in this case. What we want to use is the other prime that's there. If you had, say, 7 and 5, right? And you were trying to add those 3/7 and 4/5. You would multiply this by 7 over 7 and 5 over 5, right? We're doing the same thing here. The same exact thing. I'm going to multiply this by a minus 4 over a minus 4. And I'm going to multiply this by a plus 2 times a plus 2. Okay? It's a factor of 1, right? But I'm using the other denominator in order to make them so they look the same. These look the same now, right? A plus 2 times a minus 4. A plus 2 times a minus 4. Okay? And so when I rewrite these, I'm going to have them as a plus 2 times a minus 4. Okay? Just that one denominator. But with the top, I'm going to have it as 4a times a plus 2 plus 2 times a minus 4. The reason why I wrote this like this is just so you could see what it looks like before we start multiplying. So now I'm going to multiply. Bing, bing. So that's going to be 4a squared plus 8a. Plus, okay? Now that means I'm adding everything in here. Now if this is a minus, like the next problem will be, you're subtracting everything in there. Okay? Which changes all their signs. Okay? But right now it's just, I'm adding everything. So that's 2a and negative 8. Okay? And since I'm adding, it doesn't really matter what I'm doing, right? I'm just adding. So now I'm just going to collect like terms, right? Where I have a plus 2 times a minus 4. And I want to collect my like terms. 4a, well that's just 4a squared, right? But here I have my a's, so that's 8 plus 2 is 10. And then I have minus 8. Okay? All over a plus 2 times a minus 4. Now I can go in and tell, does anyone know what a cannot be right away? What is it?
Cannot be 2 and cannot be 4.
Close.
Negative 4.
Negative 4 and negative. No, sorry. 4 and negative 2, right? Always the opposite signs, right? Okay? So we know what a cannot be. Okay? And now we need to factor this out. So, GCF. What goes into all of that? 2. What's left? 2a squared plus 5a minus 4, right? Alright. Let's think about this. 2a squared plus 5a minus 4. That would be 2a plus, and the minus tells me they're the same or different? Different.
Oh, wait. Sorry.
Okay. Different. Okay? Alright, what multiplies to be 8, right? Because 2 times 4 is 8. And what subtracts to be 5. Okay? Anything? I mean, there might not be anything. I don't know. What multiplies to be 8? You just kind of have to think, well, I know it's 8 and 1. I know it's 2 and 4. And I know it's, that's it, right?
Yeah.
So nothing subtracts to be 5, right? So it's not even factorable. Okay, that's fun. So that's done. So it's 2 times 2a squared plus 5a minus 4 over a plus 2 times a minus 4. Whereas a cannot be negative 2 and 4. And that is your answer. Okay? Now, their answer in the book kept it as 4a squared, but